Assalamualaikum warahmatullahi wabarakatuh, and very good morning. Today I want to introduce you to another design that we call it Latin square design. Yeah? And we have seen before that completely randomized block design is used to reduce the experimental errors. Yeah? And of course there are other designs that use the blocking principle. Yeah? To introduce you to this new design that we call it Latin square design, first let's look at this example. For this example, is a Latin square design example where, let's say, a researcher studied the effect of different formulation of an explosive mixture used in the manufacturing of a process. Each formulation, in this example, each formulation is mixed from different batches of raw material. And furthermore, the formulation are prepared by several operators, and there may be substantial difference in the skills and experience of the operators. Now, if you look at this example, in this example, first you have to find out which is the treatment. I already mentioned that the treatment is the one that you want to compare in the study. Or you want to see what effect that you want to see on the response. That will be the treatment. Okay? Now, in this example, we have seen that we want to study the effect of one factor on the response variable, but there exist two extraneous factors that will affect the experimental result. So what are the factors? What are those two factors that will affect the experimental result? We can see from this example. Well, to do this experiment, we need raw material. So if we use the same raw material, then this raw material will not affect the experimental result. But in this example, we use different batches of raw material. So different batches of raw material will affect the experimental result. Furthermore, we see that in this example, if we use the same operators, then there will be no effect of the operators on the response variable. But since we use different operators, several operators, then these operators will affect the experimental result. So in this situation, completely randomized design is not suitable to analyze this data, because if you remember, for completely randomized block design, there exists only one extraneous factor, but in this example, we have two extraneous factors, that is the batches of raw material and the operators. So the question now, what design that we want to use to analyze this type of problem? Now, the appropriate design to use consisting of testing each formulation exactly once in each batch of raw material, and for each formulation to be prepared exactly once by each of the 5 operators. And resulting design, we call it Latin square design, where the design is a square arrangement. So you know that if we want to analyze 5 treatments, then we will have 5 rows and 5 columns. Similarly, if you want to compare, or you want to compare 3 treatments, then there will be 3 rows and also 3 columns. So let's look at this example, another example that I want to show you here. Let's say we want to see the effect of 4 different methods on the employee's productivity. But now we see that, to do this experiment, we see that there are 2 extraneous factors, that is the different days, and also 3 operators that will affect on the employee's productivity. Okay? So you see from here, we have different days, 3 days here and 3 operators. Meaning, here there's a mistake. There's a mistake here. Actually, you want to see the effect of 3 different methods. 3 different methods on the employee's productivity. So since the treatment, we have 3 treatments, then we need 3 days and 3 operators. And if you look at this arrangement, yeah, for the Latin square design, if you have 3 treatment, then you will have 3 rows and 3 columns. Yeah? And each treatment, let's say I look at treatment A, appears once in each rows and each column. So this is suitable for the Latin square design. Now, so once you have the once you look at a problem, then you have to first decide what is the problem, what kind of design is suitable for this problem. Then what you have to understand, look at the characteristic of the Latin square design. First, we have to know that the primary aim of the Latin square design is the same like the completely randomized block design, that is to analyze the effect of one factor on the response variable. But if you remember, for the completely randomized block design, there exists one extraneous factor that will affect the experimental result. But here for the Latin square design, there exists 2 extraneous factors other than the treatment that will affect the experimental result. So this makes the difference between the block design and the Latin square design. And here another point to raise here is that the blocking variable, how you do the randomization. Here the blocking variable in 2 directions, represented by rows and columns. For completely randomized block design, the blocking variable is only in 1 direction, that is in the row column. And furthermore, each treatment appears once and only once in each row and column, as already mentioned earlier. Now, once you identify the problem of the Latin square design, then you have to know how to do the randomization. To do this randomization, first you have to know the standard Latin square design. What is standard Latin square design? So a standard Latin square design, where the first row and the first column consists of letters written in alphabetical order. If you see that Latin square design in this arrangement, we call it Latin square, standard Latin square design. So let me show you. The standard Latin square arrangement. Let's look at this example. Let's look at this example. Let's say you want to study the effect of 3 treatment A, B, C. 3 treatment on the response variable. Then how is the arrangement of the Latin square for this? So we have let's say like this: A, B, C, B, C. Okay? Now, if you have 2 treatment, then you will have 3 by 3. 3 by 3 square arrangement. Okay? And as I already mentioned, for the standard Latin square arrangement, the first row and the first column is arranged in alphabetical order. So look at this, first row A, B, C, alphabetical order. A, B, C, in alphabetical order. Then the rest of the arrangement, the treatment here will be B, C, A, B, C, A, and C, A, B. So you see from here, from this arrangement, from this 3 by 3 arrangement, that each treatment appear once and only once in each column and in each row. So this is called standard Latin square arrangement. First, you have to understand what is standard Latin square arrangement. Then we look at how to do the randomization of the treatment to the experimental units. Now, well, here there are three types of randomization of the treatment to the experimental units. Let's look at the first one. to assign the treatment to the experimental unit. So what you do, for t equal to 3, independently arrange rows and columns at random. Yeah? This is for t equal to 3. For t equal to 4, yeah? Select one of the standard square at random, then independently arrange rows and columns at random. Yeah? Now, here I want to show you, because for t equal to 4, the standard Latin square arrangement, there are 4 arrangements for this. Yeah? For t equal to 3, 3 equal to 5 and more, there's only one arrangement except for t equal to 4.